Hello, we will solve now an exercise dealing with polar coordinates. Let's start with this exercise. It's exercise 15. The polar coordinates of a particle are given by r equal 2e omega t and theta equal omega t. So we are told that in this exercise we are using the polar coordinates. R is defined by this expression and theta is defined by this expression omega t. Question A, find its speed. So we need to find the magnitude of the velocity vector. So let's start with the definition of the velocity vector. The velocity vector can be written in polar coordinates as r dot ur plus r theta dot u theta. Here, ur and u theta are unit vectors. You can write instead of ur, you can write er. It's the same, okay? It means the unit vector along the radial direction. This is for er or ur, and u theta is the same as e theta. Okay, and this way of writing, we are not putting an inverse v here, but u theta as written here designates a unit vector. Where is the vector? Well, the vector is simply symbolized by the bold here, by the bold font. Okay, so what differentiates this r and this u? R here is a scalar, but u here is a vector because it's written in bold. Okay, so v is also here in bold, so this is a vector. Okay, these are just different ways of writing. So this is the velocity vector in polar coordinates, but we don't have r dot, we have r. We don't have theta dot, we have theta. So let's derive r and theta with respect to time to find r dot and theta dot respectively. So we have r equal to e omega t. R dot is equal to dr over dt. It's equal to 2 times the derivative of e omega t with respect to time is omega e omega t. And the derivative of theta with respect to time is theta dot, here it's equal to omega. So we can continue writing the velocity vector in terms of omega and t. And then we can deduce the speed of the speed v. It's equal to the radical of r dot squared plus r squared theta dot squared, and this is equal to, so this term squared plus r squared is equal to 4e2 omega t times theta dot squared is omega squared. And then we can see that here we have the same quantity. So we have omega squared e exponential, we have omega squared exponential. Here it's multiplied by 4 and here it's multiplied by 4. It means that we have radical of 8 omega squared e to omega t. And this can be simplified by writing 2 omega e omega t radical of 2. From where did we get this radical? In fact, you will obtain here radical of 8 omega squared e omega squared this exponential of 2 omega t. And radical of 8 is 2 radical of 2. Okay. So we found the speed v. Question B, Deduce the path length S after 2 seconds. So we need to write the definition of the path length. The path length is defined as the integral of the magnitude of v dt. Here v designates the magnitude of v and not the velocity vector. Okay, please pay attention to this. So the magnitude of v that we obtained from the previous question. So we put v here and inside the integral, and we'll obtain the integral of 2 radical of 2 omega e omega t dt, and we don't forget the boundaries of the limit. It's between t0 here is equal to 0 and t. You can in fact at a first step keep this as t. It's better to keep this as t, and then replace t with 2 seconds. Okay, but in this exercise they choose to we choose to keep this as 2 because this is the last question in this exercise. If there is any further question C, D, so we should for sure write the path length as a function of t, and then replace t with the numerical value. And finally we find S equal 151.5 meters. So here the integral is very easy to calculate. Another application on the polar coordinates is in exercise 16. So we have here a ladder of a fire track. We see this fire track and we see a ladder. So the ladder of a fire truck is designed to be extended at the rate L dot equals 0.5 meter per second, and to be elevated at the constant rate theta dot equal 2 degrees per second. So we can see that the ladder here can be extended. First, we can see from the figure that we have a fixed length here. This length can be extended by L. Okay, this is the extension, okay, to reach a certain floor, for example. And also the angle theta between the truck and between the, let's say, between the horizontal axis X and the ladder, this angle theta can be changed with time. It can be changed with time to give more flexibility, okay, to elevate the ladder to a certain height. So we have two variables that can change here, L and theta. The rate of change of L is L dot. It's equal to 0.5 meter per second. So here you can see that this means that we have a certain speed, and the constant rate of rotation is theta dot equal 2 degrees per second. And also here we can see that we have here a certain speed, but this is the angular speed. As the position theta equal 50 degrees and L equal 15 meters is reached, determine the magnitudes of the velocity v and the acceleration a of the fireman at A. So they said in the question that here we have a fireman. In this position, the fireman is at L equal 15 meters, and the ladder makes an angle theta equal 50 degrees with the horizontal direction. So we are asked to find the magnitude of v and the magnitude of A. So which coordinates should we use in this exercise? Do we use the Cartesian coordinates? Do we use the cylindrical coordinates? For sure, the cylindrical coordinates will not be used here because if we write if we draw the x-axis like this, the y-axis like this, and therefore the z-axis will be perpendicular to your screen. Okay, z is a constant, so we will either use the Cartesian coordinates or the polar coordinates in this exercise. Okay, but look, it seems that you have an angle theta. It seems that we have a certain rotation, so it's more convenient to use the polar coordinates. Okay, so let's start with the polar coordinates. Let's write v. In polar coordinates, we know that v is equal to the radial component of the velocity vector. So we have vr er, or vr ur, it's the same, plus v theta e theta, and vr is equal to r dot er plus v theta is equal to r theta dot, and we don't forget the unit vector e theta. Okay, do we know r theta? Yes, for sure we know r theta. R theta is in fact this L theta. Why? If we write r, let's write the position vector. So the position vector r, which is equal to OA. Okay, this is equal to the magnitude of the position vector times a unit vector ER. So let's draw ER and let's draw E theta on the figure. So here we have a certain, we can see that we have a certain circle. Okay, so we can see that this is the radius. The radius here is equal to 20 plus the variable L. So it's equal to 20 plus L. And we have, what is ER? So this is the radius. Finally, we can draw the radial direction. It's pointing toward increasing R. So this is ER. And how can we draw E theta? E theta is a vector, a unit vector, which is perpendicular to ER. So it's like this, and it's in the counterclockwise direction. So this is E theta. Please note that E theta gives you the direction of the rotation. Okay, so this is theta and this is E theta. Okay, so it's clear now where is ER on the figure and where is E theta on the figure. Okay, so R is equal to 20 plus L ER. Can we find R dot? So R dot is equal to d over dt of this quantity. So let's start. We can see that R is equal to 20 plus L. So R dot is equal to L dot, which is equal to 0.5 meter per second. Theta dot, do we know theta dot? Theta dot is equal to 2 degree per second. But degree is not a unit of angle in the SI system, so we must convert units from degree to radians. We know that pi in radians is equal to 180 in degrees. So 2 degrees is equal to 2 pi over 100 to obtain the angle in radians. Okay, and radians is the angle of the angle in the SI system. That's why we need to convert here the degree to radians. So finally we will get a v theta, which is equal to r theta dot. R theta dot is equal to 2 degrees, and we will obtain 1.22 meter per second. So we have VR and we have V theta. We can finally deduce the magnitude of the velocity vector. It's equal to the radical of VR squared plus V theta squared, and the answer is in meter per second. So please pay attention to this conversion, okay? Please attention to this conversion. Okay, now we need to find the acceleration. The acceleration is given by, in polar coordinates, it's given by r double dot minus r theta dot squared. So we know that r is given by 20 plus n, and we know that r dot is given by a constant. So r double dot is the derivative of this constant, so it's 0. And you also know that theta dot is a constant, so theta double dot is also a 0. So we can deduce AR and A theta. AR is equal to, as we can see, R double dot minus R theta dot squared. We can replace each term with its value to obtain AR equal minus 0.0426 meter per second squared. And we can deduce as well A theta. It's equal to R theta double dot plus 2R dot theta dot. We said that theta double dot is 0, so this cancels. And therefore A theta is equal to only one term. It's equal to 0.0349 meter per second squared. The question was to find the magnitude of V and A, so we need to continue to find the magnitude of A. It's equal to the radical of AR squared plus A theta squared, and it's equal to 0.0551 meter per second squared.